I'm Ed Baker, and this is How the Hell Does That Thing Work with Ed Baker. You know all this stuff. Now we're going to talk about lights and darks. Now, you know an incandescent bulb? That's the kind you have in your house, the round one. Has a little base on the bottom, has a thing up here. And it's got stuff inside it that makes light, right? Okay, let me tell you how that works. One of these little things comes down here to the side where the threads are. One of them comes down here where the little button is. There's a little piece of wire right in the middle between there like that, right? Now electricity comes in here. It goes out there. And the electrons traveling through the wires come up here, and they hit resistance here. And they're really ticked off about it. And they start moving around real fast, you know? And the more you move, it's like rubbing your hands together like this, you know? And they get real hot, just like your hands get hot when you do this. And then it gets so hot, it just gets red. And then it gets white. This is all really quick. And then the white heat is turned into light energy. And it goes out, you know, like this. Like you see it in the comic books. But now what about those darn fluorescent lights? Well, I asked an engineer about that once, and he explained it to me. Well, let me tell you what he told me. Now, how the hell does that thing work? A fluorescent tube in your ceiling fixture works like this, according to my engineer friend. Got a little transformer in there. Now, the electricity comes in from the wall, just like everywhere else. Comes in here, and these 4 wires come out and go to each end of the tube. All right? Now, this creates a buttload, a whole lot, a truckload, bunch of electricity. And what this electricity does, it gets in this tube, and it does not emit light. It sucks up dark. It sucks up dark. Now, you might be thinking, no, Ed, that's not how the hell that thing works. But it is. Let me explain it to you. You notice when you're near the fluorescent tube, it looks like there's a lot of light. That's not it. There's just very little dark there, because it's all being sucked in. As you move further and further away from this fluorescent tube, it starts getting not less light, but more dark, because the tube's not absorbing as much. And that's how I was told a fluorescent light works. What time is it? Yeah, we got plenty of time. Let's move on to the next one. That would be solar energy. Now, we got this whole dadgum thing over there in the Middle East, right? Everybody's pretty ticked off about it. Well, here are a few ways that you can save energy by utilizing perhaps the world's largest nuclear reactor, the sun. Let me tell you how. This is the sun. Yeah, up here. Not to scale, okay? This is the Earth. Woohoo! Really not to scale. The sun's energy is the result of a big nuclear reaction. There's helium, and hydrogen, and all kinds of atoms up there banging around, you know? And it's like this. And they get hot. And they come out in the form of light, kind of like the incandescent bulb, only bigger, much bigger. And this light comes to the Earth this way. Now then, let's say a chunk of that light is bounced back off by the ozone. Well, I mean, less than it was, 40 years ago, but some of it still is bounced away. Some of it gets through. Now, as it passes through the atmosphere, it creates a little bit of heat. This light is converted into heat. When it hits a solid object, or a liquid, a dense liquid, it is actually converted back into heat, which is what it was when it was up here at the sun. All right, let me explain that to you. I know you're probably thinking, Ed, how the hell does your brain work? Well, I'm not going to try that one, but I'll try this solar energy thing. Energy in the form of light leaves the sun, comes to the Earth, And what gets through the atmosphere comes down and goes through the atmosphere, which is gas. Gas is not as dense as liquid or solid, so it doesn't offer much resistance. Now, when this light hits something that is denser than the gases of the atmosphere, say, it starts the little atoms in that piece of solid or liquid to moving, like this. And it gets real hot. Now, if you contain that, say, in a box with a piece of glass over it, then you can, let me show you. Let's say this is a box, or a coffin, and you got two sheets of glass here. The light comes through here, hits this solid here. If it's painted black, dark things absorb more heat out of the light. Light-colored things reflect more of the light away, all right? Then if you poke the hole up here, and you poke the hole down here, this other process called convection. How the hell does convection work, Ed? Well, let me tell you. This process called convection would cause air to enter here, it'd get hot, it'd go up, and it'd come out here. Now, if you ran this from your basement into one of your windows, all that heat would come into your house. Presto! Solar energy! Convection. How the hell does that work, Ed? Let me tell you. As a thing gets hotter, all the little atoms and molecules rub together like this. And they start moving away from each other. It expands. The space between the atoms and molecules all get bigger, and it becomes lighter. Because it's, if it's dense, lead is very dense. Air is not very dense. Air goes up, lead goes down. Helium, oxygen, helium goes down, oxygen goes up. Okay, as it gets hotter, it's less dense, it's lighter, and it goes up. If it's cold, they move together. Like, if it's real cold at the bus stop, before high school, remember that? And you'd tell a girl down the street, get closer, it'll be warmer. That's what the molecules do. Well, they're not as crude, of course. It's the same thing. And they come closer together, and they get denser and heavier, and they all drop. But that's how hot air goes up, and convection works. How are we doing for time? Okay, you can see it on your TV, can't you?